Alright, good morning, dear students. Welcome to our first lesson, which will all be about vectors. So, the word of the day is vector without an S. Whenever you hear the word vector from me, I would like you to think of any directions that you can possibly think of. Like, for example, north, south, east, west, and so on. So, because I can't really ask something from you since this is a synchronous class, I would just like you to do that on your own. All right? Again, when you hear the word vector, I would like you to think of any directions. All right? So, for today's challenges are the following, or these are also our goals in order for us to go over to the next topic. So, number one, we will have to differentiate vector and scalar quantities. Two, we'll perform addition of vectors. Three, rewrite vectors in component form. And number four, to calculate the directions and magnitudes of vectors. Right? So let us begin. And we will start it with a story. So Miss Casey, your physics teacher, is a billionaire. Oh, di ba, Laisho? And I have given or I have hidden a gold bar somewhere. And I would like to give it to Dora the Explorer. You know Dora Mano. And I told Dora, hey Dora, I have hidden a gold somewhere. However, you will not be using the map. You will only be using these following information that I will give to you. Okay, I told Dora, letter A, that the gold bar is hidden underneath the sofa 2 meters away from her. Letter B, I told Dora that it is 2 meters away from where she is standing. And letter C, I told Dora that it is 2 meters north from where she is standing. So, which of the following informations do you think is the most useful or more useful? Right? So, we will be answering that one later at the end of our lesson. So, abangan. Okay? So, when we talk about vectors class, vectors are physical quantities that have both magnitude and direction. Please take note of the word magnitude and direction. When you talk about vectors, magnitude and direction come together. For example, we have here displacement of 2.0 north. So it has a magnitude which is 2.0 meters and it has a direction which is north. So this is a vector. We also have a velocity of 60 kilometers per hour east and a force of 40 Newton west. So again, whenever there is a magnitude given and there is also a direction, so we can call that value as vector. All right? Okay, let's go over to the brother of vector. So the brother of vector is scalar or scalars. Scalars are any physical quantities that have only magnitude. So magnitude ragyod, no direction for scalars. Okay, let's have for example here speed of 60 kilometers per hour. No direction, so this is a scalar quantity. A time of 3 hours, of course, this is also a scalar. And a temperature of 28 degrees Celsius or Fahrenheit, this is also a scalar quantity. So since we already have differentiated the vector and scalar, so you can now answer this, right? So, for example, I'll just have a vector of 5 kilometers west. So that's an example of a vector quantity. For scalar, you can just write 5 kilometers. So this is talking about displacement or distance. So again, the difference between vector and scalar is that vector has magnitude and direction, plus direction to vector, while scalar only has magnitude. Okay? So let's go on. When we talk about vectors class, vectors in different directions, do you think we can possibly add them? Because when we talk about scalars, like for example, we have 5 kilometers plus 3 kilometers, we can just simply add because scalars don't have direction. But what about the vectors? Can we add vectors knowing that some vectors really have different directions? Yes, we can. So we have three ways on how we can add vectors. First is the easy way, which is simple addition. Second is using the Pythagorean theorem. And the third one is the component or the analytical method. So let's go over to the basic way on how we can add vectors. So simple addition. Let's have it here, vectors in same direction. You will just simply add the two magnitudes and keep the direction because of course they are of the same direction. So for example, we have here 3 meters east plus we also have 1 meter east. So since they have the same direction, which is east, so you will just simply copy east and then add the magnitudes. So 3 plus 1, that is 4. Right? So that's how you can easily add vectors in same direction. So let's put it in a problem format. So we have here a man that walks 54.5 meters east. So the man walks east and then another 30 meters east and then another east direction. So to calculate his displacement relative to where he started, so you can just simply add 54.5 plus 30, which is 84.5, and then copy east. So when you are asked about displacement, this is about the magnitude and the direction. Okay, we will talk about displacement further in our next topic. Right? So what about vectors in opposite directions? So vectors in opposite directions, we will just subtract the two magnitudes and the direction is same as the greater vector. Right? So we will subtract and copy the direction of the greater vector. For example, we have here 4 meters south plus 2 meters north. So south and north are opposing directions. South and north, right? So what we will do is we will simply subtract 4 minus 2, that's 2, and then copy the direction of the greater vector. So we will copy south, since south is greater compared, since 4 meters is greater than 2 meters. Right? So that's how we have the final answer, which is 2 meters south. Okay, to put it in a problem format, we have here a man that walks 54 meters east. So this is just the same with the problem we had earlier, but the difference is the directions. Then 30 meters west. So to calculate his displacement relative to where he started, so since they are opposing directions, so we will just simply subtract. So 54.5 minus 30, we have 24.5 meters east. So copy east because east has the greater vector compared to west. Right? So easy. So again, when you have opposing directions, you will just simply subtract and then copy the direction of the greater vector, and if you have the same directions, you will just simply add. Now let's go over to the vectors in Pythagorean theorem. Okay, so to use the addition of vectors in Pythagorean theorem, we would have to recall the a square plus b square is equal to c square. So this is the Pythagorean theorem. Okay, so looking at our example, we have here 5 kilometers east and then 3 kilometers south. So since we cannot simply add these vectors because this is east and this is south, we cannot use the principle we learned earlier. So what we're gonna do is we're gonna put the resultant vector, or let's just draw the Cartesian plane first, and then we will connect the vectors from the starting point, and then we will call it as the hypotenuse. All right, can you still remember this is the hypotenuse, or we call this the resultant vector, or RV. So for this example, this is C, this is I think A, and this is B, right? Okay, so our goal here is to get C. So how do we get C if C is still squared? We have it here. Let's just copy the Pythagorean theorem, a squared plus b squared equals c squared. Then let's transfer c squared to the left side and a squared plus b squared to the right side. So we are just transferring the different variables. So our goal is to cancel out the square in the c square. Okay, so we can do that by putting square root to both sides. So we can now cancel the square in C, and then we can't cancel the square in A and the square in B because A square plus B square is one entity. You can't simply cancel the square in A and in B unless if this is drawn this way or written this way. So if that is written that way, so you can simply cancel. But since it is not, so you just need to copy a square plus b square. So this is just a review of your algebra. So since we have it here in our example, we have RV is equal to square root of a square plus b square, and our A is this one, and our B is 3 kilometers. So we have square root of 5 square plus 3 square. So if you calculate it in your calculator, you have the answer 5.83 kilometers. Now you have the magnitude. But since this is a vector, we are to look for the direction. Okay? So in vector, we call theta as the direction. This is the symbol for theta. So let's draw the Cartesian plane from our example. So when you try to draw the Cartesian plane, we put our theta here inside our right triangle. So that's our theta. How do we solve for theta? So we will solve it using our knowledge in trigonometric functions. We have the SOHCAHTOA. Again, so here we call this as the opposite. This is the opposite of theta. Okay? And this is of course the adjacent, and this is the hypotenuse, right? Okay, going back, sine theta is equal to opposite over hypotenuse, or the hypotenuse is RV. Cosine theta is adjacent over hypotenuse, or our resultant vector, and tangent theta is equal to opposite over adjacent. So from our given earlier, we have here the adjacent, which is 5 kilometers, the opposite, which is the 3 kilometers, the opposite of theta. We're talking about the theta here, and we have the calculated resultant vector, which is 5.83. So actually, class, we can use all of the trigonometric functions since we have the values already of opposite, hypotenuse, and adjacent. But if you can notice, if you try to calculate again resultant vector, it's not really exactly 5.83. Naapa na siya sumpay. So it's not really that accurate. So to solve for the accurate tangent, or I mean accurate theta, we will use the tangent because the given for the tangent theta is equals to opposite over adjacent. And our given in the opposite is a whole number, which is 3 kilometers. And our adjacent is 5 kilometers. That's also a whole number. So it's more appropriate